Hey, what's up, guys? So today I'm going to show you how to make an FPS movement system, and hopefully by the end of this video you should have something that looks pretty much like this. So you can jump around, pretty smooth movement. You can slide down ramps and you'll gain speed. You can also launch off the ramps, and yeah. So hope you enjoy. Alright, so I've just made a new URP project here. I've added some assets to test the movement with. And this movement system in particular will be using the new Unity input system. You can, however, completely adapt this to use the old input system if you'd like. Um, but keep in mind that that system, I'm pretty sure it'll definitely be around for quite a long time. However, at some point it will be phased out. So I'm going to show you how to install the input system package here. So you're gonna wanna go to Window, and then Package Manager, and then that'll bring you here to your Package Manager. And right here, you can go to the Unity registry. And then you wanna scroll down and find the input system right here, and then just click Install. Now it will ask you to restart your editor, so I'm gonna do that really quick, and I'll come back. Alright, so I've just restarted my editor, and now we have the input system installed, as you can see here, version 1.02. Now, alright, so first things first, I'm going to get started by creating an empty object. This will be our player container. This is what's going to hold our camera, our player object, everything that relates to the player. So we're going to make that first, and then reset the transform so it's not off out in the middle of nowhere. And then I'm going to just create a new 3D object. I'll do a cylinder for now, I guess. And then I'm going to move this up by 1. So then we can move it from the base. I just find it easier to do it like that. Just to be able to pivot it from the bottom there. Alright, anyways, I'm going to name the cylinder player. Then I'm going to add a rigid body to this. And I'm just gonna up the mass here a little bit, and I will explain this later on why I am doing this, but yeah, I'm also gonna turn on interpolate here. This will basically just slightly delay the rigid body from moving, if I'm correct. If somebody has a more detailed explanation of that, please put it in the comments. But this helps with camera synchronization issues, which personally I had a lot of when I was first trying to make this. So we're also going to freeze our rotation here, just so we don't start rolling around. Alright, so now we're going to make an object to hold our camera. So we'll just call this camera. Reset the transform there. We're going to also drag the camera to be a child of this camera object. Going to reset that transform. And this is good for now. We'll add something here later. Now I'm going to add 2 empty game objects here, and I'll explain what both of these do here in a second. So I'm going to name this one head. And basically you just want to position this wherever you want your camera to be. So this will basically be the viewpoint that the camera goes to, and where you see from. So yeah, we'll set up the head there. This is basically the only purpose for it right now. And then I'm going to name this one orientation. And this will be the orientation of your player. Yeah, just basically wherever you're looking, on the horizontal side of things, left, right. Yeah, stuff like that. Alright, so now let's set up our controls with the new input system. Alright, so do this wherever you want. I'm just going to right click here in the File Explorer and go to Create, and I'm going to, let me see if I can find it here. At the bottom here, I'm going to make a new Input Actions, and I'm just going to call this Controls. And then let's open this up by double clicking it. Alright, so these are your control schemes right here. So I'm going to make a new action map, and I'm just going to call this Gameplay. And I'm just gonna delete this one. and just completely make a new one. Alright, I'm making a new one here, and I'm going to call this movement. And I will right click on the movement tab here and add a 2D vector composite. And you can name this whatever, I don't think it matters that much. I'm going to delete this binding here too. Alright, now I'm going to put our bindings here. This is, WASD, basically your up, down, left, right. So I'm going to assign W here, assign S for down, A for left, and T for right. Alright, so that's done. Now let's make another one here. I'm going to call this one mouse. And we're going to have to set this one to be a value of type vector2. And then here we're going to go to the mouse tab here, and we're going to click delta. This will just, this is just your mouse position in relation on the screen. Yeah, this should be good for now. We'll come back to this. So now I'm just going to press Save Asset up here at the top, and make sure you come up here to the top right in your inspector, and make sure you click on Generate C# class and press Apply. This will just generate a class that you can use in your scripts to basically mention your controls. Alright, so I'm going to make a new C# script here, and I'm going to name this the PlayerController, because that's what it's doing, it's controlling the player. Alright, I'm going to open this up as soon as it compiles. Alright, here we go. Already zoomed in. Alright, let's start with our mouse look. So I'm going to start by making a couple of fields here at the top. Start with a header actually, because this is more organized, and this basically just separates your, what's going on here? Header is not valid. It is only valid on field tick. Oh, right. Alright, so, sorry. Mouse look settings, and then we're just going to make a private transform here. Player camera. Just going to initialize this to null. And serialized field basically just exposes this value to the editor. It's like making a public variable, however, this still restricts the access to this script. So now I'm going to make another one. Serialized field private transform orientation equals null. These are pretty self-explanatory. This will just be your player camera, and this will be the orientation, the object we just set up a couple minutes ago. Now I'm also going to create a new instance of our controls here. So I'm going to make a private controls. Now this is referencing that script, C# script that we just generated with our input actions asset. I'm just going to name this controls. And then I'm going to just delete these two functions here. We'll make them again later. And I'm going to make an awake function. And in here I'm going to say controls equals new controls. This will just create a new instance of that script within this scope. So we can use it here, and to use the new input system, we're also going to have to make on-enable methods, or on-enable and on-disable methods. So right here we're going to say controls.enable. This will just enable your controls, and then we're also going to do on-disable and do controls.disable. This will obviously disable your controls. Alright, so now we should be completely able to use these. Yeah. Alright. So first we're going to make our update method. And we're going to write a method to gather our inputs. So let's call this update inputs. And we'll make a new private void update inputs. And in here we're going to say hold on, let's go up here and create a couple vector 2s. So we're gonna make a new vector 2, call this move input, and we'll just initialize that to vector 2.0. And then here we're gonna make another vector 2, and we're gonna call this mouse input, and also initialize that to a vector 2.0. This is basically just an empty vector 2. All right. So in our update inputs method here, we're gonna assign our move input to be controls, and then we're going to reference whatever our control scheme that we named. So in my case, it'll be gameplay. And then here we're going to reference what we put that 2D movement vector in earlier. So I'll show you right here. This will be our movement right here, right? This is where we put the 2D vector. So then we're going to open this up and we're going to say dot movement. And then we're going to have to, this isn't enough. I don't know why. You're going to have to put another thing here at the end. Dot read value. This is a method, and this is basically what we want to read. What we want to, read our value as. So we're going to do a vector 2. And this will basically just store your WSD inputs in a vector 2 and movement. And now we're going to do basically the same thing for mouse input. So we're going to do controls.gameplay dot mouse dot read value vector 2. Alright, cool. Now we have our mouse there. Let's also make a sensitivity variable here too. Private vector 2 sensitivity. Sensitivity equals new vector 2. I'm just going to initialize this to 2020. This is what works for me. It'll probably be different for you. Now, here we're going to we're just going to multiply our mouse input right here by our sensitivity. We're also going to multiply by time, delta time. And yeah, that should be good for now. I might do I'm going to do a sensitivity multiplier. This is not needed. This is personal preference, but this is just what I like to do. Do like 0.2f. Alright, and then we're also going to multiply this by the sensitivity multiplier. Alright, so this is basically our input setup. Now we can get started on the mouse look. So we're going to need a variable here to track our X rotation. So we're just going to make a new float here. We're going to call this X rotation and just initialize that to 0. Now we're going to make a new method here and put this in update and call this update mouse look. Alright, and then let's make that here, private void update mouse look. Alright. So first we're going to want to store our current rotation of our camera. So we're just going to say var rotation equals player camera dot local rotation dot Euler angles or Euler angles. This will be a vector 3. I'm just going to redo this to a vector 3 for clarity reasons. Typically, I just put everything in vars because it's just faster for me, but personal preference completely up to you. So we're going to make another float here, and this will basically be the X position we want our camera to move to. So I'm going to name this X2 and say this will be our rotation, which is our current camera rotation, dot Y, plus our current mouse dot X, mouse input dot X. Yep, there we go. All right. So now that we have this, we can say X rotation minus equals mouse dot Y. So if you were to do plus equals here, mouse input dot Y, this will basically invert your mouse input, which obviously we don't want, so we're just gonna subtract it. And then yeah, all right, let's start editing our rotation now for our objects here. So we're gonna say player camera dot local rotation equals quaternion dot Euler, whatever, can never pronounce it correctly. And quaternions are fucking confusing. Excuse my language. I honestly don't really understand them that well, so I don't really know how to explain this too much. But this is basically here. I'll just read this to you. Returns a rotation that rotates z degrees around the z-axis. Whatever. This will basically just apply a rotation in a way that it can understand. So we're going to say our x, what x rotation we want is going to be our x rotation, and then our y is going to be our x2, and then I'm just going to set the z here to 0. And then we're going to do orientation.local rotation. We're going to do another quaternion.Euler. If I could type. And then right here, we're just going to do 0, x2, 0. And this should be working now, so let's just save. And then I'm going to head back into here, and let's try it out. Okay, so it's not working. Alright, so completely sorry about that. I forgot to do something very important. We need to make a script here first, and we need to name this the FollowCam. This is a very simple script. This is basically just gonna follow your player around. So we're gonna do serialized field, private transform, target, or player. You can name it whatever you want. And then we're gonna make an update function. And we're just going to say transform.position equals target.position. This will just, track whatever the target is. So we're going to go back into our editor here, and we're going to throw the FollowCam onto the parent camera object, and we're going to set the target to be our head on our player. So this will follow the head. And then here on our player, me being an idiot completely forgot to put the PlayerController script on here, so obviously it'd be a good idea to put that on there. Now we're going to put our player camera here. This will be your parent camera object, and we're also going to put the orientation here. Alright, now it should work. Alright. Yep, here we go. So it's working. Can't move. The mouse isn't locked to the screen, which we can fix. It's very easy to fix. But yeah, we can look around. But however, one issue you may notice is that we don't have a restriction at all to how far up and down we want to look. So we're going to fix that too. So let's head back into our player controller here. And we're going to go to our wake function, and we're just going to say cursor.lockState equals cursor lockMode.locked. This will just lock your cursor to the center of your screen, so it's not, flying all over your monitor when you're just trying to move. And now we're going to clamp our angle here. So we're just going to make a new serialized field. We're going to call this, we're going to make a float, and we're going to call this max angle. And I'm just going to set this to 90. And right here, we're going to want to clamp our X rotation. Okay, so X rotation is basically your up and down. We're just going to clamp our X rotation here up and down to negative max angle, our minimum, and then max angle as our maximum. And this should just fix the problem of, spinning around without any restrictions whatsoever. And then we should also have our mouse confined to our screen now. So let's see if that worked. It works. So now we have restricted movement on the up and down, and we can turn around just fine. Everything's working normally. Alright, so now we can get started on the movement. Alright, so I'm just going to start here by creating some movement settings. So we're going to go up here, make a new header, call this movement settings. And I'm going to make a new serialized field of type float and name this move speed. Let's just set this to 500 because this is going to be need to be a decently high value here because we're going to multiply by time delta time. And you know what? I'm also going to add another float here, and we're just going to call this move multiplier. This is what we'll multiply our move value by, just in case we don't want to set it to something like 5,000, to get some decent movement going here. Yeah, so we'll set that up first. Now, let's make a fixed update function. So down here, I'm just going to make a fixed update. This is the internal physics update on Unity, or for Unity's, script execution order. And I'm going to put a method here that we haven't yet created. I'm going to call this update movement. Alright, and let's just make that down here, private void update movement. So first things first, we're going to want to make a new vector3 here. This will be the direction we want to move in. And this is where our orientation comes in. So remember what I said earlier about the orientation basically being where the player is looking horizontally. And this will, define obviously what direction we move in. So we're going to say orientation.right. This will be, relative to the orientation. We're going to multiply this by our move input dot x, and then we're going to add orientation.forward times move input dot y. This will be the direction we want our player to move in. Now we should just be able to add force. Oh, I haven't even made a reference to the rigid body. Alright, I'm just going to go up here and make a rigid body reference, call it private rigid body RB. And I'm just going to go in awake here, and I'm going to say RB equals get component. Oops. Rigid body. Alright, there we go. Now we have a reference to the rigid body. So we're going to say RB.add force. I find that this has much more natural movement compared to other methods, there's like transform.translate and whatnot. Anyways, we're going to say direction. So the direction we want to move in. So this will be the direction of our force. Now we're going to multiply this by our move speed. Times our, I'm just going to put this in parentheses for clarity reasons. You don't have to do this. Move speed times our move multiplier. So this will be how fast we want to move. Times time.fixed delta time. This is basically delta time, but it's for physics. Essentially, that's, the interval in seconds at which physics and other fixed frame rate updates are performed. Alright, so, this should be good for now. So let's go ahead and test it out. Let's see if we move. Now, you're going to notice immediately that it's slippery. Very slippery. And we'll figure this out. I'm going to explain why this happens and whatnot. Well, I mean, it's kind of obvious. We're using add force here, so it's adding it over time, and we don't really have any drag. And I personally, I'm not going to use drag because, in my experience, I don't know if this happens for other people or whether I was just doing something wrong because, I'm not the smartest. It caused camera sync issues, so it'd be very laggy, like choppy when I was moving and whatnot. So yeah, what we're going to do is we're just going to go to our materials folder here. If you don't have this, you can just make one pretty easily. And I'm going to make a new physics material, and I'm just going to call this ground mat. We're going to take off all the dynamic friction, all the static friction, just make it 0, 0, 0. And you want to put this on everything you want to walk on, or that is going to be ground. I also recommend putting this on walls because your player might just get stuck in the walls when you're trying to move him. Stuff like that. Anyways, so that should be good now. It'll still, have the same slippery movement, but we're gonna fix that. Now let's make a new. All right, let's make a new field here, which will basically be our drag. Let's see here, drag. And I'm just going to set this to 230. This is what I found works the best for me. And we're going to make a new function here. Call this, put it right under here, call this private void apply drag. And we're going to need to give it a direction in which to apply the drag in. So right here we're going to say vector3 direction. So this will be an input variable. And then we're going to check first if we're moving. So if the rigid body velocity magnitude, which is just the length of the current vector, is not equal to 0, so we are moving. In this case, we're going to want to add force in basically the opposite direction. So this will be the direction we input. We're going to say direction times drag. times time.fixed delta time. And this will just apply drag in the opposite direction that we're moving. And up here in our update movement, we're going to call this function. We can do it right here, and we'll just say apply drag negative rb.velocity just rb.velocity. So this will send in our rigid body velocity, so our velocity in the current direction we're heading in, and just return it negative. So this will be the direction we want to apply in. So obviously if we're applying drag, we're going to want to apply force in the opposite direction that we're moving, so we slow down. So yeah, that should start to slow us down a bit. And if this value here of drag doesn't work for you, then obviously change it how you wish. So yeah, as you can see, now we got some pretty smooth looking movement for now. Now I would, if you don't like this, obviously play around with the values more. The higher the drag you get, the more snappy your movement's gonna feel, because you're gonna slow down faster. For example, if we set this to like 300, you stop quicker. So there's that. What we're also going to do, hold on, I'll show you really quick what we're going to want to do. I'll demonstrate this. So right now, there's literally no restriction on your speed. So you can just keep going in one direction and speed up 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 and speed up. And you don't want that. You don't want to just move in one direction and hit like Mach 2. So let's set that up. We're gonna go in here. We're gonna make a new field up here. We're gonna call this the max speed. I'm just gonna put this under the move multiplier here. Just gonna say private float max speed. And personally, I like 20. You can change this to whatever you want. That's what I found's worked for me. And now we're gonna go into our update movement function, and we're going to alright, so what most people here would do is that they'd adjust, the velocity of the rigid body, so it doesn't go over the max speed. However, what I personally like is zeroing out the input, because in the future when we add sliding, I don't want my sliding to be capped by a move cap. I want to be able to build up a lot of speed and go really fast, while I'm sliding down things. So we're gonna say here that if our rb.velocity.magnitude is greater than max speed, then direction equals vector3.0. So this will just zero out in the direction that we're heading here. And I'm just going to go and update here. You don't have to do this. I'm just doing this for demonstration purposes. I'm going to write our velocity here, magnitude, to the console so we can see what's happening. So yeah, our magnitude, you see it's not going really over 18. And this won't be exactly on what your max speed is, but however the max speed will be, applied at 20. But as you can see now, we're not like overly speeding up in any direction. We're staying at a stable speed, which is what most people would probably want in their case. So yeah, there's that. I'm going to get rid of this line here. All right, so let's get started on jumping here. So we're going to go to Unity first. I'm gonna go to our controls. I'm just gonna clear the console here because it's cluttered. And we're gonna add a new action, and I'm just gonna call this jump. And we're gonna wanna add a button here. We're gonna look for space. And yep, just assign space to there and save asset. This will also update the script that it generated. And now that we have that button, we can go back into the script here and we can say, so I'm gonna show you how to assign input actions. I like to do this on start, but I think it'll work just fine in awake. Alright, We're going to say here controls.gameplay.jump. So this is basically just the same way you reference this. However, we're not going to be reading a value here because this isn't a vector 2. You can think of this as basically an action, right? So we're going to want to say dot performed, which this is an event, and we're going to want to add a basically a listener, a subscriber to this event. So we're going to say plus equals context to on jump. That's a method we haven't created yet, but we'll create it here soon. And this will basically just call this method when you perform your jump key, right? When you press space. So I'm gonna go down here, and I'm just going to put right under apply drag here. I'm gonna put our method here. I'm gonna call it on jump. Oops. All right, and we're gonna add a ground check here, but I just want to make sure our jump is working here. So we're gonna just for now we're gonna add force, and we're gonna do vector2.up. This is just what I found is easier. This will be 1 in the positive y direction, and we need to make a couple more variables here. Gonna make a new header. Call this jump settings. Add a new serialized field. Call this private float jump force. And what's a good value for this? 300 is what I've set. And we're also going to probably want a jump multiplier that we can change. Like I said, it's kind of the same thing with the movement here if you want to just increase it by more. And we're also going to make a couple more here that I will explain at a later date, or not a later date, but here in a minute. I'll just skim over them, what they basically do. So we're going to make an in-air movement modifier. This is going to adjust how maneuverable we are while we're jumping. And then I'm going to make another float here. Call this in-air drag. This will just be the amount of drag we have while we're in the air, while we're off the ground. Alright, so back to our jump method here. We're going to multiply this by jump force. Then we're going to multiply this by just the jump multiplier for now, I think. This should work. So we're jumping for now. However, it's barely even noticeable. Why is that? Oh, we need to change our gravity. Alright. So yeah, we'll figure. You just play around with your jump force multipliers and whatnot. But what's important is that we got him jumping. Let's up this by a little bit. We're also going to need to adjust our gravity settings here in a little bit. Let's just throw this up to 600. Fuck it. So yeah. However, you can tell that it's very floaty, and we'll fix that. It's like moon gravity right now. The default Unity gravity is the world gravity negative 9.81 or whatever it is. But we're gonna change that. I don't know how good this is to do, but this is just something I'm going to do. You can always change this for yourself. Let's see here. What am I doing? We're gonna go to project settings in our edit tab here, and we're gonna go to physics. Yep, that's what I was looking for. I'm gonna change the Y gravity here to negative 30. And just make sure that saves. Control S. And this should kind of help our gravity here. We might go and add some more. Yeah, that helps quite a bit. We might go change our. Yeah, we're gonna add some more gravity as well in the script. So there's that for now. We're gonna go back into the script here, and we're gonna apply some extra gravity. Just because I think it feels better in my opinion. So we're going to do RB to add force. This will be down, so vector3.down. Times, let's do time.fix delta time, and then times, so let's just do 10. can adjust that. You can make that a field up there if you want to adjust it in the editor, but what I found is 10 works just fine. So we're gonna have 10 here, and we're gonna, yep, that looks like it's helped out a bit. So I'm just gonna raise the jump settings here. 5, yeah, there we go. It's quite a bit overboard, and we're still a little floaty. Yeah, I would just play around with the gravity settings probably. We're also gonna be adding our drag and stuff here in a little bit, so yeah. So just play with the gravity if you want. All right, apply drag. That's where we're gonna be. So let's do. Oh right. You know what? We're gonna do that in just a minute. First, we're gonna add a ground check. We're gonna add a ground check here because this is kind of reliant on whether we're grounded or not. Right? We need to be able to make sure that we're in the air if we want to apply inner drag. So we're gonna make a bool. This will return bool, and we're gonna name it ground check. And we're just gonna do a simple sphere cast. A sphere cast is basically just a ray cast, except it comes down in like a sphere. So it's bigger. So we're just gonna say physics.spherecast transform.position. So this is where our player is, and then we're gonna have to add some settings here for a ground check. So I'm just gonna add another header here. Call this ground check settings. And here we're going to want to make a serialized field, call this private float ground check radius. We'll do 0.4. This is basically just how, the radius of your sphere cast, so how big you want your circle to be. And then we're going to make another one here. This will be the distance at which we raycast, so how far we can go. So we're going to name this ground check distance. Just put that at 1 unit, 1 meter. And we're also going to need a layer mask. So we're just going to say private layer mask ground layer. So this is just what's going to be detected as ground. Alright, so we'll save that, and then we'll go back down to here, and we're going to say our ground check radius. Sorry, that's the distance, ground check radius. Then the direction in which we want to raycast, so vector through that down. And then we're going to need to output the hit info. We're not going to be using this right now, at least. Actually, yes, we will be using this because we're going to need to detect the slope currently that we're on for later on for sliding. So right now we're going to say out raycast hit. This will make a new variable of type raycast hit named hit. And then right here we're just going to put our max distance or ground check distance, and then we'll put in our layer mask, ground layer. Alright, so there's that. Then we're just going to return grounded. Yeah, this should be a ground check. So in our jump function now, where do we put it? Right here. I'm just going to say if ground check. So if we're grounded, then we jump, because we obviously don't want to be able to jump, over and over and over again without touching the ground first. So we're going to do that. Go back in here. Keep forgetting to turn up the multiplier and stuff. So we'll just set that to 5 here, and then we'll add our drag and stuff here in a minute. So, but just so you can see that you can't. Oh, right. Completely forgot to make a ground layer. Anyways, alright, so you're going to want to make whatever you want to be ground, in the ground layers. So we'll just come to here, we'll select all this, and we're going to go to add layer right here. I'm going to put in a new user layer called this ground. And then here, here, and here, we'll just make this ground. And then also on the player, we're going to need to select our layer mask here for ground, just ground, the one we just made. Now we should be able to jump. There we go. So as you can see, be spamming space. I'm sure you can hear me do that. You can't jump while you're in air. So great. that's working. All right, what next? Our drag, right? All right, so here's our drag function. We're going to start to apply an air drag. So we're going to say if not ground check, so if we're not on the ground, then we're going to first add force. We're going to say a new vector 3, because so for now, so basically we're inputting our velocity, right? When we jump and we start to come back down, this is obviously going to give us velocity in the y direction, so our gravity that we're manually applying. And if we just said direction here, it would apply drag also to our falling speed, so it'd make us feel more floaty, which obviously we don't want. So this is why we're creating a new vector or vector 3 here. And we're just going to say direction.x 0f, because we don't want anything in the y direction. We don't want to be applying drag. And then here we're also going to put direction.z. And of course, we're going to need to apply this by, or we're going to need to times this vector by our in-air drag that we made earlier. And then we're going to also multiply by time.fixed delta time once again. And then we're just going to return, because we don't want to be applying drag here, because, you know, this is when we're walking. So we're just going to return early. So we don't do that. So, all right, that should slow down our jump when we're moving forward and back, of course. So as you can tell right now, as you can see when I'm jumping, you know, I speed up a lot, which is something that some people don't like, so just turn that up. And I guess that's, is that working? Let's just go overboard here and check if that's working. Yep, that's working. You might just need to go a bit overboard here at the values, however, but yeah, as you can see, it's working as intended. All right, so there's a drag. Well, let's get to crouching and sliding and stuff. So we're gonna come in here. Let's see. All right, we're just gonna make a new header. We're gonna call this the slide and crouch settings. Right now, we're not gonna be adding any sliding settings because we're not implementing that just yet. I don't want to create a whole shit ton of variables and just confuse you guys. So for now, we're just going to make a vector 3, which will be our crouch scale. So this is basically just the an easy way to do crouching. So we're just gonna set that to half of our Y scale, right there, and then I'm gonna also apply a crouch jump modifier, because what you'll notice is that it kind of seems like we are going higher when we're crouching, which really you're going about the same height. However, it just looks like it's more because, you know, your player's vision's halved, right? So we're gonna make a crouch multiplier here. We're just gonna do 1f. And now we're also gonna need a bool here. So I'm gonna make a new bool. Private bool, gonna call this just crouching. This is detect whether we're crouching or not. And we are gonna need a new control. So let's head back into the Unity editor. Let's open up our controls here. And right, we'll need to apply our in-air movement modifier as well. Sorry. So we're gonna add a new action here. We're just gonna name it crouch, and we'll do left control. Left control. This is personally what I like. You can do C or, you know, whatever button you prefer. Alright, that should have updated our script. And we're gonna head back in here now, and this is essentially the same thing that we did before with the jump. So we'll just say controls.gameplay.crouch crouch dot performed plus equals context to toggle crouch, which is something we haven't yet made, but we will make it. And then this is a new event that I haven't showed you yet. So we're gonna do controls.gameplay.crouch.canceled. This will be when we release the crouch key, and we'll say we just want to toggle crouch false, so we want to stop crouching. We are also going to need a vector up here, private vector 3. This will be our original player scale that we want to return to when we're not crouching anymore. So I'm just going to initialize that to vector 3, that's 0. And then in here on awake, I'm just going to say original, sorry, this shouldn't be original player. Original scale, sorry, my bad. We're going to go down into awake here, like I said before, and we're going to say original scale equals transform.local scale. So that'll just be our, our original scale. Alright, so let's write our toggle crouch function here. So private void toggle crouch bool. We'll just call this enabled. And now what we're going to want to do is say if enabled, then we're going to want to set crouching to true, the bool we just made, and then we're also going to want to set our local scale, our current scale, to be our crouching scale. And along with this, we are also going to want to offset our current position so we don't get stuck in the ground. We're going to want to offset it by, create a new vector 3 here. And we'll do our current transform.position.x because we don't want to offset on the x at all, but we do want to do transform.position.y minus 0.5f. And then we'll just do transport.position.z. And this will be so you don't whenever you crouch, you're not like in the air and then you fall, which is pretty ugly. I mean, I don't think anyone really wants that. And now we're gonna implement our uncrouch. So we're gonna do if not enabled, so else crouching equals false. Then we're also just going to want to set our transform.local scale to our original scale. And we'll want to do transform.position equals new vector 3. This is just, actually, you know what? For simplicity reasons, we can literally just copy this line and change the minus here to a plus. This will just offset the player, half a unit into the air so we don't, come back and elongate and get stuck in the in the ground. Alright, so this should be good for now. We'll also implement sliding here in a minute. Go ahead and test that out. We're also going to implement our crouch jump modifier here in a minute. Crouching will come into play later. However, you can see we're crouching. Alright, cool, that works. So now that we've got that set up, I'm going to implement the in-air movement modifier, the crouch jump modifier, all that. So let's start with the crouch jump modifier. So we're going to go into our on jump here, and I'm going to use what is called a ternary operator. So this is basically just a simplified if statement, and in simpler terms. So we're gonna just say basically this will be if crouching, and this is basically our if statement. So if crouching is true, then we're gonna want to use our crouch jump multiplier, and otherwise, if crouching is false, we'll use a colon here, which will basically act as the else statement. And that'll just be our jump multiplier. So we'll just say, if crouching, then use our crouch jump multiplier, else jump multiplier. Um, and this should be enough to just apply the jump modifier here. This will be pretty noticeable, I think, considering our other. So yeah, here's our normal jump, and then here's when we try and crouch jump. Of course, we made this as a setting, so I'll set that to 3, and then you notice we jump a lot shorter than you do when you're standing. Which makes sense, because obviously when you're crouching, it's not like you can like slap squat into the air. So yeah, that works. Now let's use our inner movement multiplier. We're going to want to do that in our update movement function up here. So we're just going to make a multiplier here for our movement. So I'm just going to say float multiplier equals, so we're going to use another ternary operator here, simplified if statement. So we're going to say if grounded, so if ground check. If that returns true, then we're just going to want to keep our normal movement. So if we're on the ground, we're just going to multiply that by 1, which will return, you know, the original value. Because if, or, so else, in-air movement modifier. So this is just saying if we're grounded, then use 1, which will, you know, just give us the same value, or we'll use our in-air movement modifier, which will make us less maneuverable when we're in the air. So now that we have that, we are going to come down here. We're going to say where we times fixed delta time, we're just going to do times multiplier, and then we're going to times by the multiplier again, which is just something I personally like to do. We'll do ground check if you're going to use another ternary operator here. If we're grounded and crouching, so this will be for sliding later. So if we're sorry about all the parentheses here, I know it's a little bit confusing. So if we're grounded and crouching, then we're going to want to do 0 because I don't want to be maneuvering on the ground. Or actually, we can make this smaller. We can just do something like 0.03, whatever. You can make that a thing up there, like a variable if you want. Personally, I don't think I need it. And then we'll use our colon here, or else, and just say multiplier. So I'll just explain that because I'm sure it's probably confusing. So here, if we're grounded and crouching, which means we're walking while crouching, we're going to multiply our movement by 0.3, which will reduce the multiplier, which will make us walk slower while we're crouching. Or we'll just use the normal multiplier here, right? So if that's not the case, if we're just normally standing, then it'll be our normal movement, but if we're jumping, it'll be this up here, so our in-air movement modifier. That's where that ternary operator comes in. So now if we go back in, we should be able to see that this makes us less maneuverable and slower while we're crouching. So, yep. So it's kind of hard for me. I'm holding A right now to strafe in air, and then when we're crouching, we move a lot slower, which you can change this, of course. I might change this as well to maybe like 0.7. Yeah, because I don't want to move much slower than I do when I'm in there. You can also make this 0 if you don't want your player to move at all when you're crouching. So yeah, let's do sliding now. This should be pretty easy to implement. Yeah, it shouldn't be too hard. So here we're gonna want to say this is going to apply a bunch of force to us while we're grounded and crouching. So basically when we're sliding, we can make this more comprehensive later once we actually have more sliding ways to detect whether we're sliding. So for now, we're just going to say if crouching and grounded. So if crouching and ground check. Then we're just going to want to add a bunch of force down, so it keeps us on the ground and we don't, like go flying off a ramp or something. Let's just do 5,000. And then we're going to want to return early, so we don't apply all this stuff. This will also make it so when we're sliding, we can't move in other directions, which I don't like. So yeah, there's that, but that's not going to be just enough to apply our sliding here. So we're going to need to go to our toggle crouch here and then say if enabled, so this will be right when we press control. We're going to want to say if our RB, rigid body velocity magnitude, is greater than 0 at least. So I'm just going to do 0.5, so we're definitely moving and going fast enough. And we're grounded. Ground check. Then we're going to add force, RB.add force. We're going to do orientation, so the way in which we're facing, dot forward, times a variable we haven't made yet. I'm going to name it slide force. And I'm going to scroll up here. We're going to go to our slide and crouch settings, and then right up here I'm just going to make a new serialized field called this private float slide force, and I'll just give this a value of something like 600. We'll go with 600. Anyways, back down here. Oh, we're also going to need to make another bool here, so I'm just going to comma and then sliding. So this will just make another bool named sliding, and I'm going to come down here where we're initiating our slide. I'm going to set sliding to true, so we know that we're now sliding. And then in our else statement, we're also going to want to say sliding equals false. Oh, that's slide force. Sliding equals false. There we go. All right. Let's see if this works. Yep, it kind of works. So here's a force thing I was talking about. So if you try jumping and shit while you're on the ground, you can't, but it's noticeable. You'll have to play around with the values to stop that. But you notice, this isn't me moving. This is the force that's being applied to us when I crouch. Because obviously I can't move now when I'm crouching, but yeah, there's this. Now we're gonna come back into here and we're gonna make this more slippy, kind of like an actual slide here, rather than kind of like scraping against the floor, which isn't smooth. So we're gonna come up here and we're gonna make a new variable. I'm just gonna call this serialized field private float slide drag. Set that to 0.1. Alright, so now we're gonna come back down here to our apply drag function, and right under here we're gonna say if crouching, then add force, our move speed times time.fixed delta time times negative rb.velocity at normalized times slide drag. And then we're just going to want to return early here. And this will make our sliding movement feel much more slidey, I guess, more smooth. So let's see here. Yeah, sort of. Yep. This will be more noticeable if I raise this here. That might be a bit too too much. Okay, but yeah, as you can see, you know, we're much more slidey. I'll demonstrate again really quick by changing the drag this time. Say this is a drag on point 1, but if I raised it to like 10, you see we'd stop much faster, but if I raised it, or if I lowered it down to something like 0.01, we slide a lot more. But personally, I like 0.1. Feels like you slow down a lot quicker. Or towards the, it feels like you speed up and then slow down a lot faster towards the end of your slide, which is something I want. Which means also we should be able to go down ramps now. So let me just get up this ramp and start sliding. Yep, there you go. You can slide down ramps. And this is because of the extra force we're adding towards, you know, when we're crouched, so we stay on the ground, because normally you just kind of like fly off of it. But yeah, that works now. It's pretty fun. Alright. So we're also just gonna really quickly just come down here and say if we're not already sliding in our toggle crouch function. Should have done that earlier, but I don't think you really need this here, but it's just to make sure. Just to be 100% sure we're not adding this force in any other case. However, there's one thing I want to show you. So, our sliding can be abused right now in this state. So, for example, you can just spam slide, and this will constantly apply force, because, you know, you're spamming your crouch key, right? So a way I found to do this is just to add a slide cooldown. So let's head back into here, go back up to our slide settings, and just right under slide drag, we're going to say serialized field private float slide cooldown. And I'm just going to set this to 1 second. Then we're going to come down to our update function. We're just going to say if, let's see here, if, we're also going to need another float, sorry. Let's make another float here, private float time since last slide. And then I'm just going to initialize this to mathf.infinity, because technically we haven't slid before yet, right, at the time of creating this. So we're just going to do that. Come down here back to update and say if time since last slide is less than slide cooldown, time since last slide plus equals time.delta time. Time.delta time. So this is just act as like a timer. This will just, you know, increment by the time between frames. And to make this actually work, we're going to need to come down to our toggle crouch function here, where we apply our slide. And we're going to say, and time since last slide is greater than or equal to our slide cooldown. And then we're also going to want to set time since last slide equals 0. Alright, and this should stop the sliding from being abused by adding a cooldown. So yeah, as you can see, I can spam crouch now no matter how much I do. I don't consistently add force anymore, and I just stop, which is what we want. Another thing, we are probably going to want a slide jump modifier, so we can actually get some height while we're sliding, you know, while we're jumping. So we're going to come up here, we're going to say, right under slide cooldown, I'm going to make another serialized field, call this private float slide jump modifier, or multiplier. Set that to 2.5. Then I'm going to come back down. What was it? On jump. We're going to go down to on jump. And then here, our ternary operator. This is probably going to get a little confusing. First off, we're gonna need to know whether we're actually sliding or not. And we have enough speed. This is not needed. However, this is something I like because you will be able to gain a lot of speed when you're slide jumping, right? And typically, I don't really want to do that because I don't want my player to be able to go super fast when they don't have enough velocity. Like, I want them to be able to jump very high when they're going down a ramp and then they jump. But if they're just normally sliding and then they jump, I don't want them to, launch. So here we're gonna go up and we're gonna make another new float. We're gonna call this one private float current slope. Initialize that to 0. And this will just be the angle of the current slope we're on. We can put that in our ground check because this will we're always going to want to know what slope we're on as soon as we check whether we're on the ground or not. And this just makes the most sense to me to put this in here. So we're going to do some math in here. We're going to say current slope equals vector, why did I say it like that? Vector 3 dot angle, vector 3 dot up, and then hit dot normal. The normal of the surface, the ray hit. So this will just be our raycast hit here. So the object we're hitting below us, so in this case a ground object, and this will get the current angle of what we're standing on. So that'll be useful when you're going down a ramp, right? You can tell that you're going down a ramp. So now we're gonna go back to our on jump here, and it's possible to basically nest a ternary operator within a ternary operator. And you don't have to do this. However, I like to just confuse myself. So this is how I'm going to do it. So here we're just going to get rid of this here and just keep the crouching part and say if crouching and current slope is less than 10, then we're going to select our crouch or jump modifier, or if we're crouching and our current slope is greater than or equal to 10, then we'll do slide jump modifier or multiplier, or just the normal jump modifier or multiplier. And I know that's a long line, so I highly recommend here just writing a comment as to what this does. So for example, I'll just write one out here and say if crouching and not sliding, crouch jump multiplier. If sliding, slide jump multiplier. And if all else is false, normal jump multiplier. This will just be easier when you come back to this and you're like, what the fuck did I write here? But yeah, you don't have to do this. I'm just doing this for demonstration purposes again. I'm going to write our current slope to the console so we can just see that that is working. Alright, so now we should have implemented our slide jump modifier correctly. Alright, so here we go. As you can see, our slope there was higher than 35, and I guess it was applying our slide jump modifier there. It's just you can't really tell because I guess the extra gravity. But let's see here. Yep. Yep, yeah, that worked. Alright, let's bring that down a notch. Probably something like 10 would work pretty well here. Maybe higher. We'll find out. Yep, 10 is okay. I'm happy with 10. So we'll do 10 here. Yep, there's that. Let's do sprinting. We can do sprinting, and let's do Yeah, this should be easy. Actually, really quick, I'm just gonna make this. So I'm gonna make a couple of variables here in the bool section. These are basically our states. So I'm gonna make a new state here, or a new bool. We'll call it jumping. I'm also gonna make one called sprinting for the future. So here we're gonna want to change this to be a body. But yeah, this works as well. You're gonna want to set jumping to true here. So what we're gonna do here is we're also gonna call on jump again. What we're gonna do here is that basically, if you're holding spacebar, and I want the player to be able to instantly jump again if they're holding the spacebar as soon as they hit the ground. So it's not kind of like a spam fest of hitting the spacebar to try and jump again as soon as you hit the ground, right? You don't have to do this, but this is something I personally prefer. We're also going to say here, controls gameplay jump.canceled. We're going to set jumping to false. Then we're going to want to have to come into our update movement here. And we'll say if jumping and grounded, ground check, then we'll just call on jump. And this will just make it so when we're holding down spacebar and we hit the ground, we'll just jump again. So I'll show you that here now. Not exactly sure when that changed. However, suddenly we jump very high. So I'm not gonna, guess I won't worry about that too much. Yeah, that's kind of weird. Well, anyways, I'm not complaining, I guess. But yeah, here, let me show you. When we're holding jump, just jump, instantly again. Anyways, I'm sorry if that changes randomly for you too, and randomly gets rid of all of your, or kind of basically fucks up all your values. Hopefully it doesn't. I don't know why it did that for me. But we're also going to want to come into apply drag here and say if we're not grounded or we are jumping, then we're going to want to apply the force here. Right, sprinting. So I'm going to come up here and I'm going to set up a couple new, we'll set up a few variables here. So we're going to say serialized field private float sprint multiplier. And I like 12 here, I think, is what I had it set to before. We're also going to want a setting here for max slope. I'll explain that in a minute. Set that to 15F. And we're also going to want to adjust the max speed. We're going to want to basically modify it and add to it. Because, when you sprint, it's basically right now it'll be you just basically speed up faster, right? But you're not actually heading any faster than you were before. So we're going to need to add we're going to need to make our max speed higher. Alright, yeah, that should be all we need for now. And we should be pretty much almost done here. So we're going to need to add a new control really quick. I'm going to come in here. We're going to add a new button. We'll name this sprint. And I'll set this to my left shift key. That's personally what I like. And then save asset again. Back to Visual Studio Code. And we'll add another event listener. We're going to do controls.gameplay. Should be basically a pro in this by now. .sprint. .performed plus equals context to sprinting equals true. And then just like jumping, we're going to say controls.gameplay. .sprint. .canceled plus equals context to sprinting equals false. Not sure why that's processors here. That should be performed. It's probably because I spelled it wrong first. Okay, now this will basically detect whether we're sprinting now, and we're going to want to come down to our update movement in here, and woohoo, more ternary operators. I hope you're excited. Alright, so here we're gonna, this is where we modify our movement, right? So here we're gonna want to set up a ternary operator. So we're gonna want to check whether we're sprinting, and if we are sprinting, then we're gonna want to use our sprint multiplier. And if we're not sprinting, then just our normal move modifier. That should be enough to just increase our, our normal speed here. However, we're gonna need, guess what? Yet another ternary operator up here in our max speed. And we're going to want to say if we're sprinting, then just max speed plus our sprint max speed modifier, or just normal max speed. Alright, and that should be enough to get us sprinting. Hopefully this has taught you some more about ternary operators, because they're actually very, very useful. It's good to know how to use them. But yeah, as you can see, now we're sprinting, which is very nice. Yeah. So there's that, and now I'm going to explain why we needed that slope thing. So, in games, for example, like Titanfall, you can, or Apex Legends, well, that's probably a better example, considering that's newer. Games like that, you can jump, and if you come down while you're holding crouch, you'll slide. However, in our current state, if we just came down after jumping, we'll just kind of smack into the ground and become like a very heavy hamburger, and we won't slide at all, which is, personally, I don't like that, but if you want to smash it into the ground and become a flat, heavy lead hamburger, then by all means, you can skip this part and remove that other variable we made earlier. However, I like to slide when after a jump, so we're gonna make a new method here, and this is an internal Unity one. This will be on collision enter. If you're unfamiliar with this, this runs whenever a collision gets detected on your collider or your Rigidbody. And right here, we're gonna want to write an if statement. This is gonna be quite long. So here we're going to want to first check if we are grounded. And if we are grounded and we are crouching, and we're going fast enough to be able to slide, and our current slope is less than our max slope, so this is making sure that the current slope is smaller than the maximum slope, and we're not sliding already. And time since last slide greater than or equal to slide cooldown. There you go. And guess what? This is like the smallest add force thing ever. This is basically exactly what we did to add sliding before. Orientation dot forward, the direction we are facing, times slide force. Now it's probably worth writing another comment here. Which I'm going to do because but this is pretty confusing. So I'm going to say get player to slide when he hits the ground. If is grounded and is crouched and magnitude is above the threshold. I might just lower this or remove that word there so it's smaller, because this might be a long sentence here. And the current slope is smaller than the maximum slope. And we're not already sliding. And not on cooldown. All right, all right. So there's that, and let's go play around with it now. All right, so we're jumping, we hold control, and we slide. We're jumping, and we hold control, and we slide. So it's pretty nice, and it doesn't work if you slide into a jump either, which is pretty good. Sorry for a second there, I thought the jumping was a little glitched. And we can slide down this and jump extremely high because my values are all fucked up. Um, yeah. That's pretty much. I think that's it. Yep. I think that's it. All right. So thank you for watching. I hope you learned something, and I really hope that this wasn't too confusing for you. Feel free to use this as you wish. Feel free to use this as a base. Um, for whatever you want. This is um, this is pretty much based off of Danny's movement system, the developer that's making Carlson right now. Um, uh, he helped me a lot with making this script. Just being able to reference his code and stuff really helped a lot as well. This is basically my modified version of it. Um, but yeah, if you have any questions, feel free to ask in the comments. Yeah, if I'm forgetting anything, comments. If you want to see something else, just write a comment. Um, tell me what you want to see next. I was thinking about doing a weapon system, my next video, but if you enjoyed, um, yeah, like and subscribe or something like that. Thank you. All right, bye bye.